Welcome to the second part of your second lecture, in which we're going to discuss reference model, the Open System Interconnection Reference Model, and the Transport Control Protocol Internet Protocol Reference Model. The OSI reference model was designed with 5 principles in mind. First, there has to be different abstraction for a level to be created. Second, the layer should perform well-defined function. Third, the functions of each layer have to be designed with internationally standardization protocols in mind. 4, each layer boundary should be designed so that the information flow through the interfaces is minimal. Lastly, the number of layers will be large enough to accommodate all the needed functions and small enough that it's not impractical or overwhelming. The OSI reference model has 7 layers. Layer 7 is application, then presentation, session, transport, network, data link, and lastly, physical layer. You can memorize them using the sentence, all people seems to need data processing. The upper 3 layers deals with the application, and the lower 4 layers deal with the data transport. As we have seen in our abstract model, the communication is vertical and horizontal. The vertical communication between adjacent layers is actual, and the horizontal communication between peer layers is virtual. The lower 3 layers has to deal with the subnet. That's to say the collection of routers and links that link the source and the destination networks. The communication in OSI reference model, as we have said, is between adjacent layers. So, for example, the data link layer communicates with the network layer, providing services for it, and communicate with the physical layer, invoking the services provided by the physical layer. Data link layer communicates with the peer data link layer on the destination. Now we will discuss different layers and their functions. The physical layer is responsible of mechanical, electrical, and electronic issues, such as how many volts should be used to represent 1 and how many are used to represent 0. Whether the transmission might proceed in single direction at a time or simultaneously in both directions. How the connection is initiated and how it's steered down. How many pins are in the network connector, and what is the function of each pin. That's what we call a hardware protocol. Data link layer, on the other hand, deals with raw transmission from the physical layer and formatting frames, that's to say data units, with recognized frame boundaries to transmit it to upper layers. It is also responsible of error correction, and error detection, and flow control, so to keep one transmitter from overwhelming a slow receiver in data. It's also responsible of medium access control. That's to say, how multiple senders access a single shared media, like in bus topologies, or in broadcast networks. The network layer has to deal with routing, congestion control, and how to connect heterogeneous networks. The transport layer is responsible of taking the messages from the upper layer, the session layer, splitting them into smaller segments, sequence these segments, and multiplex different connections into single channel in the receiving machine, it will demultiplex these different connections in the single channel, sending each data to the source, to the destination. And it's also desegmenting or resegmenting the messages, sending the message as a whole to the session layer. It determines how the type of services to be provided in the session layer, and it will tell which message belongs to which connection. It will regulate the flow of information. You will notice that the flow of information is regulated in multiple layers, not in single layer. The session layer deals with establishing sessions, controlling the session, and tearing down the session, and synchronizing different sessions that is running. The presentation layer deals with the presentation of data, the syntax and semantics of data, of changing the data from the local format, say text, to standard format, say ASCII. And it effectively convert from the representation used inside the computer to the representation understood by the standard network representation and back. It also tells the destination whether we are using big endian, that's to say we are sending the bit with the highest order first, or little endian, that's to say we're sending the bit with the lower value first. The application layer deals with the application using different application layers protocol like HTTP, Telnet, FTP, DNS, DHCP, and SMTP, and POP. As for the TCP IP reference model, as we have said, it has only 4 layers: host to network, internet, transport, and application. Presentation and session layers are not presented in this model. The functions of the presentation and session layer is mostly carried by the application layer in TCP IP reference model. The TCP IP protocol stack consists of, on the link layer, for example, DSL, SONET, 802.11, Ethernet. In the internet layer, there is Internet Protocol and Internet Control Message Protocol. In the transport layer, there is Transport Control Protocol and User Datagram Protocol. In the application layer, there are similar protocols to those on the application layer in the OSI reference model: HTTP, SMTP, Real-Time Transfer Protocol, Domain Name System. The host to network protocol layer is rather not present in the literature. There is so little that has been said about it. Mainly it looks more like an interface than a layer, interface between the upper layers and the actual medium. The possible connections are LAN to router to internet, dial-up to router to internet, and ADSL router to the internet. The internet layer job is to permit hosts to inject packets into the network. It creates the packets, it adds addressing, and it injects the packets into the network and forward the packets from source to destination. The transport layer is designed to allow peer entities, that's to say source and destination, to carry on conversation. It has 2 protocols: transfer control protocol, that's a reliable connection-oriented protocol, and user datagram protocol, that's an unreliable connectionless protocol. The application layer has the similar, as we have said, similar protocols, use the similar protocols that are used by the OSI reference model, HTTP, FTP, TFTP, SMTP, POP, DNS, network news transfer protocol, dynamic host control protocol, and so forth. The similarities between TCP IP reference model and OSI reference model is that they are both layered models. They both have protocol stack. They both provide end-to-end service provider and end-to-end service user. The differences are that in OSI reference model, services, interfaces, and protocols are clearly distinguished and well-defined. Well, that's not the case in TCP IP model. Originally, they were not distinguished. Later in the literature, people tried to make TCP IP more like OSI reference model in terms of distinguishing services, interfaces, and protocols. The differences between the OSI reference model and the TCP reference model continues. One difference is which one comes first, the model or the protocols. In OSI case, the model came first, and that actually created problems in implementation, where the implementers did not actually understand the model, and the implementation caused creating sub-layers in the actual model, like the medium access layer in the net data link layer, where the data link layer was basically designed for point-to-point networks, while when the broadcast network came along, they needed to create a sub-layer in the data link layer to address the medium access control. Obviously, OSI reference model has 7 layers and TCP IP has 4 layers. Network transport and application layer are common, while the rest is different. The connection-oriented and connection-less services are provided by different layers in the two models. In OSI reference model, connection-oriented and connection-less services are provided by network layer, and connection-oriented services by transport layer. Where in TCP IP reference model, the connectionless services is presented by network layer, and there is connectionless and connection-oriented services in the transport layer. In this course, we will use a hybrid model of 5 layers: application, transport, network, data link, and physical layer, omitting the session and presentation layer, because as we have said, it's of little use for most nowadays applications. And this model is adapted from Computer Networks by Andrew Stewart Tannenbaum. Your reading assignment for this week is section 1.5 from chapter 1 from Tannenbaum, and your writing assignment is mobile network generations, including a table of comparison between different generations. Thank you, and see you next Tuesday.